everyone, this is Jill Hurston with Synerzip. Welcome to our webinar today. I want to remind everybody that I am recording this session and you will all receive an email from me tomorrow with a direct link to the recording and to the slides. And anytime during the webinar, please type in any questions that you have and we'll address them as they come up. With that, I'd like to turn this webinar over to Mike Watson. He's our VP of Engineering at Synerzip, and he will be moderating this session. Mike, over to you.
Thanks, Jill, and welcome everyone to today's webinar, Creating Chaos, Engineering for the Unexpected. Whether you have requirements to support high availability, deal with load spikes, or have tight maintenance windows, you should find today's webinar very interesting. I'd like to introduce our speaker for today, Shahzad Zafar. He's the VP of Engineering at RX Savings. Shahzad, over to you.
Thank you, Mike, and thank you, Jill and Synerzip for setting this up. Before I do a little bit more, if I could ask people, we have a survey up on screen. If you could just take a minute and answer the question. So if you go to menti.com and use the code, it looks like some people are starting to answer. So if you could just please take a minute and answer the survey, that will help start our discussion. And I'll do my introduction in the meantime. As Mike mentioned, I'm a VP of Engineering at RX Savings Solutions. We're based out of Kansas City. So just this talk really came from some of my own user experiences. So as we have started implementing some of these concepts, this talk is really kind of recapping our experience with it, what we learned, what we had trouble with. So this is definitely one step in our journey today. I don't think we have reached a conclusion, or if I ever will, but at this point in time, this is definitely something we are learning, and as we're learning, this is hopefully some of the lessons learned that my hope is in the end that you as the audience will have some takeaways that you can apply in your own workplace. So as we see some of these answers coming in, it's definitely interesting, good mix. So we talk about some Netflix Chaos Monkey, and we'll cover that. Reliability, resilience, high availability, confusion and disruption. Those are topics we'll hit on as well in terms of what does chaos really mean in our topic today. So yeah, not organized. That's always an interesting one because the word, as it implies with chaos engineering, we will talk about how this is a planned activity and not something we want to do where we cause trouble in our ecosystem. So with that, I'm gonna proceed to the next slide. So yeah. Just my Twitter handle that's at the bottom of the screen. If you want to reach out to me, that would be a good way to reach out. So why this topic? Really, essentially, when we think about chaos engineering, where we started from was if you look back to the history of computing, they started off as very centralized systems, right? So mainframe systems where everything went through one node. As computers evolved, we became more decentralized, right? We still had more systems, which are interconnected, but they were still they were still pretty centralized, but you just had more failure points. Today, where we are at is we are really looking at distributed systems. So per Leslie Lamport, a distributed system is one in which the failure of a computer you didn't even know existed can render your computer unusable. And I thought this was a really good definition in my head for distributed systems. Is today the inherent complexity in our systems are generally so high that every once in a while we have failures that we hear of that happens in our system where I didn't even know that I depended on that one component and maybe a third-party repository. And we'll go over some of these examples. So really, when we talk about the distributed systems that we have, it's to get ourselves resilient against those unknown failures. And this is a recent example. So at DevOps Days KC in Kansas City in October, There was a talk on chaos engineering, and I saw this definition, and I thought this was perfect description of what is chaos engineering. Really, it's like a vaccine where we're injecting harm to build immunity to failure. So if you look at from our system perspective, we know our systems will fail. We know there will be issues that will happen. Is how do we become resilient to those failures? So when those failures happen, we recover gracefully. We are fault tolerant, as the survey at the beginning somebody also answered. That's really our goal when we are talking about chaos engineering. The crux of chaos engineering is really all about experimentation. That's really where it originated from, and that's what our goal is. So to put some more definition around it, it's about having a hypothesis. So when we are running an experiment, right, we are generally looking at, we come up with a proposed solution or proposed problem that we have, and we think this might be a solution for it. We write up a hypothesis, and then we identify some control conditions, and then we run those experiments. And as we learn from those experiments, we try to apply them in real world also. But the purpose of doing it in the lab or in a controlled environment is to limit the scope or the blast radius, right? So we do not want to start it impacting where if we have, let's say, an e-commerce website, that it starts impacting that users are unable to place an order. So having a hypothesis is really important to know exactly what we are trying to do, but also trying to run these experiments as real as possible. And we'll tackle this last point as well, which can sometimes cause some apprehension and maybe some anxiety when we say that that we should run these experiments as close to production as possible or run them in production. So I think, as somebody mentioned in the survey at the very beginning, that they correlated chaos engineering to Chaos Monkey, which is absolutely kind of, at least from what I have learned, that is the beginnings of it. So Chaos Monkey was a Netflix project that they open sourced. And the whole idea with the Chaos Monkey was to take things out of load at a high level and see how the system reacted to it. And does it recover gracefully or not? Chaos Monkey was actually just the beginning from a Netflix perspective of what they were trying to do. From Chaos Monkey, we now have the Simian Army, and these are all projects you can Google and find out more details about. But if you think about, we talk about Chaos Monkey, and that's, I think, the more popular term we hear about. But Netflix has a Chaos Gorilla, Chaos Kong, the Janitor Monkey, which I thought was very interesting. I believe that was one where it cleans up unused resources. So it essentially keeps an eye on your system and see what's getting used and what's not getting used, and automatically cleans them up for you. So depending on the size of your system, that could be something really important. Or some of the other ones, like the Security Monkey, who was always testing for what are the security vulnerabilities in our system. So really, when we think about chaos engineering, it's a combination of all of these things. Chaos Monkey is definitely the beginnings of it. That's where it started. But I think when we think about the discipline of chaos engineering, really it's to think about holistically about the system and not just about whether a system is up or down or a component is up or down, but what are all the other things that make our system overall resilient. So from a security perspective, latency perspective, compliance perspective, all those things come into the overall chaos engineering. So we'll quickly hit on some of the principles of chaos engineering. So I think, as I mentioned earlier, having a really good hypothesis is very important. Really just starting with the why. Why are we running these experiments? So if you have heard of Simon Sinek, he's written a book and also has done some TED Talks, which are really good. But they talk about the power of why. So why are we doing this in the first place, right? If you're going to run an experiment, what is the purpose of the experiment? What do we expect the behavior to be? That's the how, right? How do we expect to run the experiment? And then the last part is what is expected to happen when we run this experiment. So working on a good hypothesis is really important. And then using real world events. So not making things up. Looking at our system and figuring out what is our high impact scenarios. That's really sometimes a good starting point as well. Maybe if you have had recent incidents in production, maybe we look at those and refining scenarios from there. Essentially, the goal with chaos engineering is to not just do hypothetical testing, but also what are the real world events that can happen in our system, that we expect to happen in our system, and building our system to be resilient to those. And the idea behind another important principle is the continuous experimentation. So today you might have some, let's say a security audit or something that's running once a year, that you did once a year. But the idea behind chaos engineering is that we are running these experiments all the time. They are done with that's like, think of it like automated testing or something you're doing with continuous integration, continuous deployment. This is along the same lines of that. This is part of our ecosystem that as we are working and developing, we are testing for a resiliency in our system. Which means that you have to spend some time automating those experiments to be able to run continuous experimentation. You might need to build some tools or adopt some tools to be able to orchestrate and analyze these experiments. See, another important one is so how to measure these experiments. Ideally, you want to use business metrics to measure experiments. We, I think, are more used to measuring output type metrics. So the first bullet point here of measuring things like throughput, error rates, those are generally our steady state system metrics, right? Those are output metrics, right? Are we getting the right transaction load, or this is the rate of our 500s that we throw. Are we going up or down? Those are the ones that are easier to measure, but those are a good starting point. But really in the end, what we want to get to is we want to get to outcomes and outcome type metrics, which is, well, what is the value add? Does it impact, is it impacting our usage of certain functionality in our system? So the idea is, for example, if we are measuring, let's say just uptime type metrics, which is an output metric, well, if I have a server that's going down, that might be a bad thing. But if my system is already built up to be N+1 or something, and that I have that backup built into it, then is it really impacting any outcome, right? It's when it starts impacting outcomes, that's when it really starts hurting our business. And those are type of business metrics we want to get to. Now, it's hard to sometimes correlate that I feel like in a more of a transactional type system where, let's say it's an e-commerce website again. If you're purchasing something on a website, if my website functionality is, let's say if my buy button is not working, then I know it's directly impacting my business at that point. So it's really important to understand, like, what are these business metrics or these outcome metrics that we should work on to try to define, and not just stay on the output metrics, but evolve to the outcome metrics as well. So we mentioned limiting the blast radius. So again, our goal is not to experiment against the whole system. We want to scale up the experiments and stop them when they start impacting business metrics. This is where, if you look at from a principles perspective, I would first understand, you have the hypotheses. As part of the hypotheses, you will define what metrics are you going to measure. What is going to tell you that this experiment is going to fail or is it going to succeed? And that's where, once you have those defined, that's when we want to start running these experiments, is because then we know that at this point, if an output metric, if our error rate reaches a certain point, or if we have a business metric, when we know it starts getting impacted, that's when we know we have reached the limit of our system. That's the idea of limiting the blast radius. So if you look at, if you use one of the public cloud providers like AWS or Google Cloud, all of them have a concept of a region versus an availability zone. The idea is that if I have my system set up to be resilient, maybe it's available cross region or cross availability zone, depending on what problem you're trying to solve. But maybe I run this experiment in only one availability zone, or I can isolate that environment and run the experiment there to start with. Even if you don't have a more complex setup like having multi-region or multi-availability zone, but even if you're running a more smaller scale business, you still have to think about resiliency, right? You still have to be at least N+1 to know that if my primary system goes down, I have a backup that I can quickly fall back to. So that's the idea of limiting the blast radius, that you start off with impacting part of your system, and the moment you think it's going to start impacting your actual business, that's when we know when to stop those experiments. And lastly, we want to run these experiments in production. It is obviously a little bit hard thing to swallow, and I would recommend that you don't start with running these experiments in production. But the idea of running them in production is that is the most realistic setup. That is actually the real setup you have from a business perspective. You can have earlier environments that look like production, but it's hard to get them to be exactly like production, have the same limitations. So that's where you want to use principles number 4 and 5 to kind of help run them safely in production. But running in production is what generally it's highly recommended. So quickly, we'll talk about kind of where to start. So if you're new to this and you're hearing about it the first time, it can be a little bit overwhelming. So to where to start, what I always recommend is start with the known weakest link. I think all of us are able to tell what our problems are, what problems exist in our system. Where do we see that we know that the process can break? That's where we want to start with to run these experiments. And essentially getting ourselves resilient to the known problems. It helps build practice, it helps build muscle memory, and then once we have resolve for these known problems, that's when we can start working through really the unknowns. Put some time in building up your monitoring system, really understanding how are you going to monitor your experiments. It could be manual monitoring to start off with. That's absolutely fine. But then again, if we want to run these experiments more frequently, if you're spending time manually gathering metrics to know how is your experiment impacting your system, you won't have time to really analyze the system. So what you want to focus on kind of automating some of that, so the load of monitoring is taken away and the system can take care of the monitoring aspects, and the person who's running the experiment can really focus on the other aspects that are not being captured in monitoring or in other places. And while running the experiments, be inclusive. And by inclusive, really talking about, think about the humans also that are part of the system. So let's say if you're running like an incident management type experiment, really taking a little bit to understand, well, if duty is going to fire off and it's going to alert somebody, does that person actually get alerted? When they get alerted, do they take the right action? Whether they have to inform others or log onto the system, whatever it may be, are they following the steps that we have kind of predetermined that in case of an incident, these are things we have to do. And really, if you haven't read the book, The Phoenix Project, that's definitely, I would highly recommend because it talks through some of these human elements and system elements of building a resilient system. But in that book, there's a character called Brent that really becomes the bottleneck. Like every time there's an issue, you have to call Brent. And if Brent's not available, then we're stuck and we are not able to resolve this issue very quickly. So really that's part of being inclusive, is that when you're talking about doing some of these experiments, don't just focus on the system. Think about your entire ecosystem, which includes humans or whatever communication mechanism you have. If you use Slack, Are we using it appropriately? Look at all those things. And that should be part of your hypothesis, is that when we run this experiment, these are the actions we expect to happen both within the system and outside the system. So with that, we have another survey question. So if you go to menti.com again, you should have the code. The code is still the same. If you can take a second and answer this question. So the question is, when do you usually make production changes? Thank you for those who have answered, and please keep answering, and I'll start talking again. But really, the purpose of asking this question is, at least from my perspective, I feel like this question generally will tell me what is the risk tolerance in your company. If you are on the far right side where you can deploy at any time of the day, the risk tolerance in your company is a little bit high, right? Because anytime we're introducing change into our system, there's a chance something can go wrong. And that's part of a resiliency question, is, right, how resilient are we? If we are saying that we have to deploy at specific times of the week, but still during business hours, you're still pretty risk tolerant. If you are after business hours or over the weekends, that tells you that the business is more risk averse. And that is something very important to understand for your organization. Because when we talked about chaos engineering, to get started on it, you have to understand your organization's risk tolerance. Because if you are in a low risk tolerance group, so if you're risk averse, so you're doing weekend deployments or after business hours, that means that if you're going to run these experiments, there will be a lot more in terms of business risk involved in it. So you want to make sure that you are running these experiments in very planned, announced events. The idea behind this is that through running these experiments, you can over time build some trust with the business that, yes, when they are announcing and telling you we're running these experiments, we don't actually impact the system because we have enough checks and balances built into it. The goal in the end is that you're able to run these experiments all the time. And I think it goes with your deployment mechanisms too, is, right? If you can able to deploy all the time, that means we have resiliency in our system, that we feel safe, that we can introduce change at any time. And if we start impacting our system, we know we can easily back out or whatever, contain that issue very quickly. The goal is with building resilient products is that we are able to run unannounced experiments at any time. And the idea is that you want to run these experiments at high risk times. So the idea behind the high risk time here is that when maybe your traffic is at peak. A great example here is if you remember when Amazon.com had an issue I think it was last month when they had the big cyber deal day on Amazon.com, and they had Amazon.com itself was having problems when a whole bunch of people logged on it at the same time. And there was some issue there. I didn't see the root cause of it, but that again is a higher risk time, right? So what happens when I'm at my peak? At that time, if an issue happens, what we're trying to see is to build that resiliency that if an issue happens at the most busy time for us, are we able to handle that? Are we able to protect ourselves against that risk? So with these experiments, we are building that, protecting our business against future losses, essentially. So it's the insurance you're paying right now to make sure that in the end, when at an actual event, when something unexpected happens, when we haven't even planned it, we are able to handle it in a safe way. and be more risk tolerant towards this. So understanding your company's risk tolerance is important to get started. From where to get started is because if you're risk averse, again, you maybe want to be very conservative in how you start running these experiments to build that trust and then move on from there. And obviously the last bullet point here, understanding the process of creating hypotheses. That is an important one because it's to really think through, you want to do some practice with how to build a hypothesis, like what are the experiments we're trying to run, what are my control conditions, what am I measuring, like we talked about in the beginning, understanding your metrics and how you're going to measure your success or failure is an important point. So when we talk about DevOps and chaos engineering, really if you think about DevOps, DevOps is more about mindset, right? It's about a culture and mindset. That's what DevOps really is. DevOps is not about the tools. The tools are just a product of it. But DevOps is really about how you think about your operational environment, your whole ecosystem, your development and your operations together. Chaos engineering is really, at least in my view, is just an implementation of DevOps, right? It's one aspect of having a DevOps culture is chaos engineering. It really forces some of the DevOps principles, like you need to have a DevOps mindset, you need to have a DevOps culture to really implement good chaos engineering. And why this becomes important is, I just took this picture off of Google, but really if you think about it, these are, in each one of our ecosystems, we're probably using one or many of these tools. Now, each one of these tools can become a critical dependency in our system. Whether we are on the development side or on the deployment side or operation side, doesn't matter. There are all these tools that are now being used interchangeably all over the place. So for us to really, given this ever-increasing tool set, we really need to understand from what happens when one of these dependencies has an issue. That DevOps mindset and behaviors are really needed to truly test through all your dependencies. System monitoring and operations need to be features from the very beginning. These cannot be bolt-ons. So when we build our new product or new project, or as we're refactoring our code, what can you put in that monitoring is super easy and deployments are super easy, because there are all these other dependencies that we are also now using. So this was from Troy McGannis's keynote on Agile 2018, which I thought was a really good code, like it said. So you have 1 and 2 to the n chance of success when you're doing something with dependencies. So let's say if you have 8 dependencies in your pipeline, that means you have 1 in 256 chance of success. So again, 8 is probably a low number. Most of us have more dependencies than that, and with each dependency added on, if you think back to the first picture we had on distributed systems, those are all my dependencies, and we are building our resiliency against those dependencies. And an example, for example, if you haven't read it, I think a couple of weeks ago, GitHub had a downtime as well, the public GitHub site, and it was down for almost a day. That again, for example, it has become a dependency for a lot of us in terms of if GitHub is down, truly we are not able to deploy or develop depending on how your system is set up. If you haven't had the chance, I would highly recommend to Google the GitHub downtime postmortem. They published it a few weeks ago as well, and it is worth a read. I would highly recommend reading it. It kind of talks through their journey of kind of what happened when they identified the issue, how they reacted to it, and then what did they learn from it. I thought it was a very good read, and it had good lessons for anyone who's running systems. So to kind of finding some of these dependencies, if you want to understand your weak points, your dependencies, your bottlenecks, value stream mapping is a concept that is really helpful. And what really, if you have ever been participating in value stream mapping exercises. It's really to map out our entire system. It's to say from inception to delivery what all we need to do to deliver a successful product. So to kind of zone in, it's really we are identifying what are the steps that happen through development, what are the people we need, what tools we need. That's what we're doing when we're building a value stream map. And that will help you identify what are my bottlenecks, where do I always get stuck, what are my weak points, what are all the dependencies, what are all the tools I need to have a successful deployment. That's what we're really trying to get to by creating a value stream map. So to briefly cover some real experiments that we have done. So some of these first ones are really from a chaos monkey perspective. So one experiment is testing failure of a load balancer or service. So this is essentially you depend on a service and that service goes down. What happens? Does that service, and what we are really trying to test is that resiliency at a component level. I depend on, let's say, using the GitHub example earlier, I depend on GitHub for something in my ecosystem, whether it's for downloading the code I need to deploy or for my deployment scripts or whatever it may be, or even just during development. What happens when that service goes down? Let's say if my load balancer is having a problem, if we just fail over a load balancer, does my traffic really handle that failover that it doesn't lose anything? Or if it loses, then how quickly does it recover? That's really a very simple experiment that you can start doing today. It really is you go down and shut something down and see what happens. That's thinking back to Netflix example, that's where Chaos Monkey started from. Getting a little bit more involved. So let's say if you have set up a system where it is N+1, whether it's an availability zone or a region, that's where we want to figure out what is a resiliency to full failover. So entire system goes down, entire region goes down, or entire availability zone goes down. Are we able to still handle the load that we have, or are we starting to impact our systems? If you look at it from an AWS perspective, for example, AWS done, I think I believe at AWS reInvent last year, they had a few talks that talked about availability zone versus region failovers. And it's really you want to understand what is your fault tolerance again in that case. So if you go back to that risk tolerance question that I had earlier, that's what you're trying to understand, right? The chances of an entire region going down are pretty slim. And that's what Amazon talks about in their talk too, is like really understanding your business. And then making sure your system is set up for failover resiliency accordingly. Do you really need to be cross-region failover tolerant, or can you just be a cross-availability zone failover tolerant? Because the cost comes into play, so you have to do the cost-benefit analysis and decide which way you want to set it up. And so Amazon will not tell you to do it one way or the other. It's entirely up to the business to decide what's the best solution for them. Going back to that load balancer or service example, another common one I think might be if you use, for example, a common OAuth server of some sort. I just thought of that. That is generally a good example of where we depend on one thing from a security standpoint, right? You might have some sort of a central security provider that all your applications are dependent on. What happens when that goes down, right? Or is that component failover tolerant? How do we handle that failure? So again, that's a good example of an experiment that you can run. Kind of thinking through more of when you have several components that fail at the same time. When we did that experiment, we had some good learnings. So it's when we took down several servers where we thought we knew all the dependencies that were deployed on them and thought we had enough failover built into it. But when the entire rack failed, or that couple of servers, different servers failed, we found some dependencies that were not designed to be resilient to failure, and that caused our system to start getting impacted. So again, this is different levels and different types of experiments to run that talk about building that resiliency into your system. And another experiment that we run that we learned from was power loss versus server shutdown. So this was something kind of we realized the hard way, or we thought it was fun. This obviously is something you cannot do if you are using one of the public clouds like AWS or whatever, because you can't really go into the data center and literally pull the power out. But if you can, like this was something the reason I brought this up was we actually saw different behaviors when we just executed a server shutdown command versus just literally somebody going in and pulling the power out. Our expectation was that the hypothesis was that the result will be the same. The system should recover just fine. It shouldn't really be an issue. But what we found out was that there were actually some dependencies that did not show up that I think when we were executing the shutdown command, I guess it failed them over properly. Whereas when we just pulled the power out, some of those dependencies stayed on and or did not shut down properly, and our system, we were actually able to find some issues in our system. So these are some of the experiments that, again, these are more, as I said, we are still in our process of running these experiments. We're still learning of what more experiments can we run. But these are some of the examples where we learned different lessons with each. I think none of these experiments worked as expected the first time we ran them. So the first time we ran them, the hypotheses, the expected results was not what actually happened. And we learned about our system and were able to further improve our system from there on with each experiment. So briefly talking about scaling beyond a team. So the idea is that obviously with any investment or any change that we do, you want to start small, right? So we said the idea is that you pick a team that is set up to be successful, that maybe already has the DevOps culture and DevOps mindset or has the right skill set. You start there to kind of vet this process out. But really, the moment you start to get beyond a team, you will need to get it out from the shadows to like a fully invested project. And by the shadows, I mean, you have one team doing it on the side, and yes, they're learning about it. But if you want to really scale this, you will need to put some real investment behind it. That means we need executive buy-in, stakeholder buy-in, who's going to fund it, how are we going to fund it? Those are all the questions we will need to answer. And part of the reason of getting investment in it is that we have to build some automation tools around it. This is not something that you can get for free. And if you, again, earlier on in the principles of chaos engineering, we mentioned that you want to run continuous experimentation. That becomes hard if you are if you don't have automation built in. Whether it's doing some sort of canary analysis, monitoring tools, controls, whatever it may be, we will have to spend some time doing some automation to it. And again, to getting to a point of running these experiments all the time. The moment these experiments start, if these experiments take time for a team to go set up, you will lose their interest. That's because, I mean, everybody has a set of projects, things that they have to go deliver, things they have to go do. Now, if we add something else on and we say now it's going to take you another week to kind of go set up these experiments and go run these experiments, while they're super valuable, again, it's to justify the cost benefit, right? That's where getting an investment in it and really making it part of your daily routine, where it's just something that's running all the time. Think of it like continuous integration. It's just running all the time. That's where we need an investment behind it. and really spend some time on it.
Hey, Shazad.
Yes.
On that last slide, did you find it difficult to get that investment from the executives, or did you have an experience that basically tipped them over the edge and made the investment easier to gain?
It was a combination of both. Some of it is that we had to. When we started on it, it was we went and did some learnings, and again we started with a small team. But to get the buy-in, essentially, it was we justified it by saying what is the cost of this downtime. So we were going to a much more centrally managed system where if it had gone down, the cost would be really high to our business. So it's relating it back to the business metrics to kind of get that buy-in. And it is to say that when we started going it beyond our team, we went in with to say that we have our core team that is going to build some of these tools. So we're not expecting every team to go build the tools. We will build the tools and we will give them to the team so that they can focus on running the experiments and not really focus on the tools. So we had essentially had to build a full business case around it and really do the cost benefit. What is a business cost of not doing it? I guess in this case, that's what we're really going for.
Okay, thanks.
So to kind of land our discussion, yeah, as a reminder, start small and grow from there. Again, don't try to boil the ocean. Start some small experiments. Start with your known weaknesses. And as you start learn and build some muscle memory, that's when you'll keep growing. And spend time writing your hypotheses. I think, as I mentioned, like every experiment we ran, the first time the hypothesis was proven false, or we failed our expected result. So you want to spend some time thinking through how are you going to measure yourself? Are you measuring the right things? We need to have we need to have automation and built-in needed capabilities. So that's the investment part. That's where we want to have, if you have monitoring and deployment capabilities or anything else, we want to build it from the very beginning. We don't want it to be a bolt-on to our system. Recognizing your risk tolerance is very important. I keep going back to that because that could hinder your how many experiments you can run and when you can run them. So recognizing that risk tolerance and working with that risk tolerance. So the goal is not to go disrupt everything tomorrow, but it's to kind of go build that risk tolerance even within our system. And part of the running these experiments is to go build that risk tolerance. So you start maybe in your dev environment, and then you move it to maybe a staging or a sandbox type environment, and then you try to get into your production and more higher risk time. So it's really understanding that risk tolerance within your organization and then building up from there. The goal is, in the end, to run experiments all the time. So even if you feel like you can never run them in production, but run them into a system close to production, but run them all the time. That should be part of our development process, is to kind of run some of these experiments to test the resiliency of our system from the get-go and not try to build that resiliency in after we have deployed something and it's being used actively. And the idea is to ensure system resiliency. We want to create lots of chaos in a friendly way. So yeah, here's some references, things which I read up and I've used to kind of learn more about chaos engineering. The first link is just, it's a book, which is a free download from Netflix that you can read up. The Phoenix Project that, as I mentioned, that's the first book. Phoenix Project, they already also had subsequent books after that, but I think it's a good starter one. Gremlin has this blog out there, which I thought, again, I heard about it at DevOps Days Kansas City, but they talked about that, and that blog actually has a lot of tools on. These are all the tools around chaos engineering that you can use, and what are the pros and cons of each. And so it's a good comprehensive guide to get started on it. So if you haven't seen it, I would recommend looking it up as well. So with that, thank you very much. And Mike, I'll hand it back to you.
Thanks, Shazad. So at this point, I'd like to encourage everyone to enter questions into the chat box. While the questions are coming in, I'm going to go ahead and give you a quick overview of Synerzip. First of all, here's my contact information if you would like to get a hold of me. I've worked with Shazad on this presentation and have some background, and I also can get you in touch with him if you need his contact information. Next slide. Synerzip is your trusted partner for agile software product development. Couple of key points is we're able to help fill in technology gaps, and obviously there's a potential cost savings working with a company like ours. Next slide. This is kind of a map of Synerzip's clients. Quite a few names here. Go ahead, go to the next slide. So next up in the webinar series is a webinar called Managing Requirements with Distributed Agile Teams. It's going to be hosted by Ranjini and Hamid, the CEO of Synerzip. Should be an interesting thing. It's actually a very important part of working in distributed teams, whether it's within your own local distributed teams or even working with a outsourcing partner or co-development partner such as Synerzip. Next slide. All right, so let's get to the questions. So Shazad, one of the things that you were saying in the presentation is that don't just test the software, you also need to test the people. I thought that was a really interesting point. Do you have any examples, extreme examples, where that's gone wrong for you?
Yeah.
Where the people were really the problem?
Yeah, we had, I remember one experiment we ran where, so the idea with some of these experiments, running these experiments, is that you run them where, so the unannounced experiments, in that case, we had an example where we ran an experiment where for one of our systems that was not in production, but it was not deployed yet even for the first time, but it wasn't ready to go to production, and we were monitoring it just like it would be a production system. And when we started kind of causing some of the chaos monkey type stuff, took some things out of load, the person who went the alert to, they did not look at the alert in the time that what we had said that, hey, if you get an alert, you have to respond within a certain amount of time. And when they looked at it, they spent a lot more before engaging the rest of the team or posting in the team channel. So those are, again, things that happen when an incident has happened, right? How do you react to it? That's where the people's actions become really important. Another one that I heard about recently was that it was actually really it happened where an alert was fired off for a real incident in production, and the person who got the alert somehow misinterpreted it and suppressed the alert. So the system was actually down for a while before somebody actually realized it was down because the alert got suppressed by the first person who got informed. So again, this is where, yes, we want our system resilient, but at a certain point, the system cannot react, and you have to have humans involved. And in that case, do humans take the right action? Are they aware? Do they even know that this is a test of our training, I guess? Another way to think about it is that do they know what actions to take when something goes wrong?
Yeah, I've definitely seen that contribute to much longer downtime when the human failure aspect happens. So how is it that you decided how big of a team you were going to put on the chaos engineering side? Do you have a thought process there? Like, how do you start small and then grow, or what are your thoughts there?
I think you start small. I think depending on how big of ecosystem you have, right, how big of your engineering department is, it kind of is, I think it's proportionate to that. But I think to start off with, I would just take a small team of like maybe 6 or 7, and maybe it is, and again, it's the best way to do it is to really learn about it. If you're building something new, you build that in as part of that. So you really set it up because you're learning the first time you're doing it. If you're building something new, you run these experiments or build that components that you need for running those experiments as part of it. So it's not something as a secondary step, but again, that might help you learn. It is not impacting anything that's in production right now. So it's a little bit more safer to run these experiments. But yeah, I would say start with a small team, like 5-6 person team, and then grow from there as you need to.
Just a quick follow-on that. Do you run that team like a sprint team, or do you add those tasks to existing sprint team work? How would you run it?
I would think that you run them like an agile team, like it's again like product planning, any project planning. Doing some of these experiments, you have to think through what are you going to do, how long it's going to take, what's the complexity of the experiment. I would say run it like any other product team that you have. It's your product here is the system as opposed to something more tangible, I guess. So your definition of product is changing a little bit, but in the end, it's still a product team.
Yeah, so you would make it a separate project than the core development effort? Yes.
Yeah. Because again, so sorry to cut in, but like you mentioned like you have to build some automation tools and stuff like that. I think the team will need to have very close collaboration with the product that they're experimenting on. Or it might be just a subset of that overall bigger team, where if you might have a squad that's a smaller team or a larger team that's focused on this. But it has to be somebody who's thinking about this more so than others. So it's a project for them.
And in your case, did you staff it with a separate team altogether, or did you use engineers from the product team to seed that team?
For us, it was the same product team that kind of part of that team started running these experiments. So we created essentially a sub-team, but it was part from the same group of people.
Yeah, that makes sense. I'm doing similar things. That's how we did it as well. So how about continuous integration and continuous deployment? You mentioned, that's something you should test. Is that, how does that fit into chaos engineering?
Those are, I think, are continuous integration and continuous deployment or continuous delivery. They're all part of when we talk about like the DevOps mindset, I think they become as part of that, is that you are continuously testing. And this, I think, helps you further. This is just another, let's explain this as like, this is just another thing that you're doing, which is part of your continuous integration. Or if you're deploying continuously as well, chaos engineering, or if you're running these experiments, that is making sure that your deployments are successful and that you are still being very resilient. You have at no point impacted our system or reduced the resiliency of our system. So this goes hand in hand with these other things. It's not a standalone. It's not something on the side. I think it complements them.
All right, that sounds good. Looks like we're out of questions. So it's a good time to end the webinar.
Great. Well, thank you very much for having me on.
Yeah, I'd like to thank you, Shahzad, and also the audience for joining today. If you have any questions that come up after thinking through it a little bit, feel free to contact Shahzad or me directly with the contact information we provided. The webinar will be available on the website, so if you want to re-listen to it or if you need the contact information, that's always a good way to get that information. Again, thanks everyone for joining, and Shahzad, thank you.